Hello everyone, I am Vishwanath Reddy and today I am going to explain you about the one of the topics of fluid mechanics, surface tension. First of all, let's go with the basic introduction of fluid mechanics. Fluid mechanics is a science in which we'll study of the nature of the fluid. There are there are different branches in the fluid mechanics, such as fluid statics, fluid dynamics. Like fluid statics deals with the fluid at rest, and fluid dynamics deals with the fluid at in motion. So, basically, in fluid statics, we'll study about the buoyancy forces and gravity and etc. And in the fluid dynamics, we'll study about the pressure, velocity, and Bernoulli's theorem, etc. in the fluid dynamics. So, in coming to the properties of the fluid, the basic properties like density, viscosity, and surface tension will be studied. So, let's go to the topic of the surface tension. Before going to the definition of the surface tension, let us know about the cohesive and adhesive forces. Cohesive forces are the forces of the between the molecules of same substance. Like consider the two molecules A, and the force between these two molecules is called cohesive forces. And adhesive forces are is the force of attraction between the molecules of different substances. Like consider the two substances A and B, then the interaction or force of attraction between these two molecules is called adhesive forces. Let us assume let us discuss with an example. Like consider the mercury have more cohesive force and less adhesive force. That's why when we like touch the mercury, the uh, it doesn't wet our hands. Whereas when we compare with the water, when we dip our hand into the water, it get wet because the force of adhesive forces are more compared to the cohesive forces in water. Now, definition of the surface tension. Surface tension, it is a property of a liquid that allows to resist the external forces. Like, see, in this figure, like we can see the fluid where there is a line and the force acting upwards. In here, surface tension is defined as force per unit length. Means like here the force is the line. Force is perpendicular to the line, uh, and the and it is also tangential to the surface area. So the actually surface tension is due to the cohesive forces. Means like means the force of attraction between the same molecules. Like see in these molecules, there are like different same molecules which will pull the surface molecules downwards, which makes the area which and because of which the area will minimize, and the layer the surface area will act as a stretching member. The units of surface tensions are newton per meter. Let us see a small example. See here like let's here there is a they given a slab placed on the slab or a plate placed on a surface of the liquid, and given that surface tension is 20 newton per meter and mass is 10 kg, and gravity is assumed at 10 meter per second square. So what here they are asking, what is the force required to lift the plank or the sheet? So what is the force required? So here mg will be acting downward, that is weight of the sheet, and the surface tension along the border of the seat will be acting downwards, opposite to the force, external force required. So, what is the surface tension acting? It is, according to the given formula, it is force per unit length. Means, so what is the force? Surface force. So what is the surface force? Surface tension into length. What is the length? Here the length is the perimeter of the slab. What is the perimeter of the slab? It is given that two length given 2 meters length and 1 meter width, means 2 into length plus width into surface tension, that is 20 Newton per meter. It will be F equal to 2 into 3 into 20 equal to 6 into 20, 120 newtons. And given that mass is 10 kgs and gravity is 10 meter per second square. So what will be the net downward force acting due to the gravity? It is mg, which is equal to 10 into 10 equal to 100 newtons. So what is the net force required to lift the plank? That is F equal to mg plus sl, or s into 2l plus p, that is 100 plus 120 equal to 220 newtons. So this is so in order to lift the plank from the surface, we need 220 newtons. Okay, let's come to the topic surface energy. Okay, in this topic, in order like in this topic, the surface tension is written in terms of surface energy. What is surface energy? The surface energy is a potential energy required to minimize the surface area is called surface energy. So how can we write surface tension in terms of energy? As here, surface tension can be written as energy per unit surface area. Like here given an example, like a water bubble. What is the surface energy of the water bubble? That is surface tension into surface area. What is surface area? 2 pi r square. Sorry. Yeah. That is 2 pi r square. So, surface energy of a soap bubble is, sorry, I mean like 4 pi r square. Surface energy of the soap bubble is surface tension into surface area. That is surface tension into 4 pi r square. So let's go to the next topic, excess pressure. The excess pressure is the difference between the pressure inside the bubble and outside the bubble. What is pressure inside the bubble? Here let's consider a water droplet which have pressure in P1 inside the water droplet and P2 outside the water droplet. The difference between P1 and P2, why P1 and P2? Here by the contour structure of the soap bubble, we can know that P1 is greater than P2. So excess pressure will be P1 inside pressure minus outside pressure. So what is the excess pressure of a water droplet? The excess pressure of a water droplet is 2s by r, that is 2 times of surface tension by radius. If we consider a soap bubble, or like which consists or air bubble, which soap bubble, which in which the inside, even the inside of the bubble is filled with the air, then excess pressure will be P1 minus P2 equal to 4s by r, because here in both the sides, in means in inside and outside, it is filled with the air. So it is twice the surface tension of the water droplet. So let's see the next topic, angle of contact. What is angle of contact? Angle of contact. It is the angle formed at the interface between the liquid and solid. Means, see, let us let us assume this is the interface between the solid and the liquid, which is solid here, and above one is liquid. The angle the angle between the interface of the solid and liquid is called angle of contact. If the angle of contact is acute, then acts as a wetting agent. If angle of contact is obtuse, then it won't wet the surface. Means like, let's see, with the see here water, it's like in the water the angle of contact is acute. Means when we pour the water we can observe that the flow of the water, how the shape of the water is formed, but water droplet is formed. But mercury, it will try to form in slight oval shape. Means like, the small curvature will be seen at the interface. It is because of the angle of contact of mercury is more. So how can we know, like, how the angle of angle of contact will depend on the cohesive forces. Means cohesive forces are forces of attraction between the same substance. In water, cohesive forces are very less. In mercury, they are more. So because of that, in water angle of contact will be in obtuse, and angle of contact of mercury will be obtuse, and angle of contact of water will be acute. Thank you.